In this video, we're going to talk about solutions. If we have 2 beakers of water with the same amount of water in each, and I add some food coloring, I'm going to add 1 drop to the beaker on the left, and I'm going to add 1, 2, 3, 4, 5 drops to the beaker on the right. You can obviously see a difference in these 2 solutions. However, they both had 300 milliliters of water and they both had the same food coloring added. So since they have the same solute and solvent in the solution, there needs to be some way to differentiate between these. And the way that we do that is by calculating their concentration. Something that's got very little solute, which is the food coloring, in the solvent, which is the water, is said to be dilute. And something that has a lot of solute compared to the amount of solvent is said to be concentrated. And there's a mathematical way to calculate that concentration and to express what is in those solutions and how much is in there. To express the concentration of a solution, we use something called molarity. And the molarity of a solution can easily be calculated by taking the moles of your solute, the thing you're dissolving, divided by the volume of the entire solution in liters. Must be in liters. Don't forget to change to moles. Don't leave it in grams, because if you do grams divided by volume, you're calculating density, not molarity. The more of the solute you dissolve in your solution, the higher this number will be, the higher the molarity will be, the more concentrated your solution will be. Here's the problem that we're going to work out. What is the molarity of a solution that has 25.4 grams of NaCl, sodium chloride, dissolved in enough water to make 200 total milliliters of solution? Remember, molarity equals moles over volume. So we need moles, and we have 25.4 grams. So the first thing we're going to need to do is change this grams of NaCl into moles of NaCl. So we need a conversion factor. 1 mole of NaCl is whatever it adds up to on the periodic table. So we need 1 Na, which is 22.99, and we need 1 Cl, which is 35.45. So our mass is 58.44 grams per 1 mole of NaCl. The grams unit cancels, and when we do the math, we will end up with moles of NaCl. So we need to take 25.4 and divide that by 58.44, which equals 0.43. And since we had 3 sig figs here, I'm going to keep 3, 5 moles of NaCl. So that's going to be our top number. We also need our volume to be changed to liters. So this was, first step was grams to moles. Second step is going to be volume to liters. So our volume that we are given in the problem is 200.0 milliliters. So we need a conversion factor. Well, there's 1,000 milliliters in 1 liter. Milliliter unit cancels. Work out the math. 200 divided by 1,000 is 0.2 0.2000 liters. So now we're ready to calculate molarity. And remember, molarity equals moles of solute over volume of solution in liters. So our moles of solute is 0.435 moles. And our volume is 0.2000 liters. So our molarity is going to be 2.17 molar. Molarity, that's the unit, capital M. There's no element with a symbol, just capital M. So this stands for molarity. And then molarity of what? NaCl. So this is your solute, and this stands for molarity. Let's try another problem, and this time let's be given molarity and let's solve for moles. So in this problem it's asking how many moles of KNO3, that's our solute, must be used to make 450 milliliters of a 0.250 molar solution of KNO3. We know that our volume needs to be in liters. So I have 450.0 milliliters. I have to convert that to liters, and there's 1,000 milliliters in 1 liter. So that makes our volume 0.4500 liters. We're being asked for moles, and we were given molarity. Don't confuse those two. So remember, molarity equals moles over liters. So our molarity is 0.250 molar. Our moles are what we are trying to find. That's our X. And our volume is 0.4500 liters. And now we're going to solve for X. So we're going to multiply both sides by 0.500, 4500, and this cancels, which just leaves us X on this side, and 0.45 times 0.25 leaves us 0.1125 moles. And we go back and look at the problem. This had 4 sig figs. This had 3 sig figs, so we're going to keep 3 in our answer. So our answer is going to be 0.113 moles of KNO3. If we were asked for how many grams it would take to make the solution, we would work it exactly the same way. We would find our moles, and then at the end we would convert moles to grams. Since there's 3 things in our equation, molarity, moles, and volume, you'll be given 2 and asked to find the third. I hope this has helped. Have a great day, and think about checking out my other videos down in the description.